In the previous video, we looked at the definition of statistics, and we also saw that statistics is simply one component of the larger research process. During the course of that discussion, two terms were mentioned, or two different types of statistics were mentioned, specifically descriptive statistics and inferential statistics. In this lesson, we will begin to take a closer look at these two types of statistics. Further, this will present an overview of the types of statistics that will be discussed in more detail later in the course. As mentioned earlier, when we talk about the field of statistics, we can divide that field generally into two parts. One part contains what is referred to as descriptive statistics. The other part is what is referred to as inferential statistics. Now, the descriptive statistics focus on the issue of practical or clinical significance, which basically means, are the results useful? Right? So when we are comparing groups, for example, practical significance or clinical significance is concerned with what is the magnitude of the difference between our treatment and our control group. Because if the actual difference in blood pressure readings at the end of the study is very minimal, then we might decide the effort and resources that would have to be invested into using this new technique for lowering blood pressure simply isn't practical. So practical significance simply focuses on the notion of, are the results useful? Now, some of the statistics that we will encounter that relate to practical significance and descriptive statistics include central tendency measures such as the mean, median, and mode, variability estimates, in particular the standard deviation, which is arguably the most common one that we'll come across or encounter in not only as part of the course, but also one of the more common ones that will be encountered in published research. In addition to the standard deviation, the range will also be a common statistic for variability. Correlations, and if we notice, correlations are grayed out, so to speak. And the reason why correlations are grayed out is that the correlation coefficient, and again we'll take a closer look at this later in the course, is actually a descriptive measure. However, when most researchers run a correlation analysis, they also associate a test of significance with that. And so that's why there is the dotted line also attaching correlation to the inferential statistics. And we'll see more about that relationship later on. But at this point, just remember that a correlation coefficient itself is a descriptive statistics. Now, things like the mean, median, mode, standard deviation, correlations, these are descriptive measures that appear across all fields of research. So whether we're talking about medical fields, whether we're talking about chemistry, physics, or education, those are measures that you're going to see across the board. Other things that maybe are more specific to health science fields would be issues such as incidence rates, point prevalence statistics, cumulative incidence, and so forth. So all of those issues and statistics would also be classified under the descriptive side, basically because they're statistics or numerical values that are trying to explain what's happening right now. Inferential statistics, on the other hand, deal with the issue of statistical significance. Now, statistical significance, kind of in layman's terms, basically is, wow, you don't see that every day. That's the gist of what we're looking at, but in a more scientific approach or a more scientific explanation, essentially what we're saying is we have found in our study a difference that was so large it was not likely to have occurred by chance alone. Now, by chance alone basically means we intervened. Now, in a treatment and control study, that intervention is presumably the treatment. By applying this new treatment, we were able to observe a difference in our two groups that was beyond what we would have expected to see under normal circumstances. In other words, if we just went out and rounded up two different groups, treated them the same way, nature says the two groups are going to be a little bit different. The two groups are going to react a little differently, just naturally, just through natural variation. But if we get to the end of our study and one group has performed unusually better, or the difference between our groups is unusually large, then we begin to believe that maybe that treatment is what caused that unusual or unusually large difference. Now, of course, this reverts back to the discussion that we had previously, which was that's only one piece of the puzzle. When we see that, we also need to make sure all the other components of the research process were conducted properly and so on. So we have these two branches of statistics. One is going to focus on the clinical significance issue. The other is going to focus on the statistical significance. Now, when you read research reports, it is possible to have a research report that is focused exclusively on descriptive statistics. There's no statistical significance involved. So in those particular studies, the only issue that is going to be of importance is the clinical significance, and you simply have to look and decide, okay, were the differences large enough? And clinical significance, when we talk about are the differences large enough, this is an issue where the researcher or the consumer, if you're the one reading the research, simply has to make a decision as to how large is large enough. And so it's a little bit more subjective. Statistical significance, on the other hand, there is no subjectivity involved in statistical significance. The formulas, things like sample size, all of that plays a role in determining that level of significance, and we will see that later on. But as I mentioned, it is possible to have articles that focus strictly on descriptive statistics. If, on the other hand, you have an article that involves statistical significance or inferential statistics, you will almost always have some descriptive statistics reported, because our inferential statistics are the ones where we're actually doing a comparison of one group to the other, or if we're following a group over time, then we have what's referred to as a repeated measures type analysis, and so we're actually attempting to compare to determine if those differences over time or differences between group are due to chance or something else. And so whenever we've collected data on these groups, one of the first things we will do is report what was the mean performance, what was the standard deviation. Then the next question is, do we go a step further and actually subject this data to an inferential type of analysis. So descriptive statistics, in some ways you could argue, form sort of the foundation, because virtually every article is going to have some measure of descriptive statistic in it. The question becomes, was that article designed in such a way to also incorporate the inferential statistics? Now, one final note as we look over this particular chart is to notice that all of the statistics at this point are simply referred to by name. For example, central tendency, we have the mean. Variability, we identified as standard deviation. Over under the statistical significance side, we have things like independent t-test, dependent t-test. It is important to keep in mind that behind all of these names lies formulas. And while computer software has basically taken over the need to hand calculate formulas, essentially, once we begin to get into the process of recognizing and trying to determine what is the appropriate analysis for this particular situation, in essence, what we're really doing is trying to determine what's the proper formula to apply to our data, or to subject our data to. This is similar in concept to asking an individual, to say, tell me the formula for the area of a shape. Well, the proper response at that point should be, well, what's the shape? Because if it's a square, then the area is one formula. If it is a triangle, the formula is different. If the shape was a circle, the formula is even different. And so what we're going to be doing along the way is not so much focusing on the formulas, but we will focus a little bit along, at each point in terms of understanding when is this particular analysis, and in quotations, formula, appropriate. And so, just as an example, the independent sample t-test, which is now hidden behind the formula, is appropriate when we're comparing two independent groups. Independent groups simply refer to the fact that the individuals in each group are unique, and there was no pairing or no matching procedure in place that would somehow suggest that the manner in which individuals in one group respond would somehow influence the way in which the others would respond. So when we look back at the research design, that will in turn influence what analysis we choose. Right? So just like we needed to know what shape we were looking at to choose the proper area formula, with, in particular, the inferential statistics, we need to know some characteristics about the study so that we can apply the proper analysis to our data. And again, going back to the previous video and the previous discussion, if the incorrect analysis is applied, then that calls into question the accuracy of the findings. And so we now have a brief introduction to the two branches of statistics, the descriptive statistics and the inferential statistics.